Okay, contracts in Solidity are similar to object-oriented languages. They contain persistent data and state variable and functions that can modify these variables. Calling a function on different contract will perform EVM function and thus the context such as the state variables are inaccessible. Creating a contract. Contract can be created from outside via Ethereum transaction or within Solidity contract. IDEs such as Remix make the creation seamless using UI elements. Creating contract programmatically on Ether is best done via JavaScript API web3.js. As per today, it is method called web3.eth to facilitate contract creation. Once contract is created, its constructor or function name as contract is executed once. The contractor is optional. Only one contract is allowed, and this means that overloading is not supported. Internally, contract constructors argument are passed API encoded after the code itself, but you don't need to care about this if you're using Web3.js. We might look at what is API encoded. So if a contractor wants to create another contract, the source code and the binary of the created contract has to be known to the creator. This means that cyclic creation dependencies are impossible. Owned contract, token creator, address name, address owner, byte 32 name. Token is a contract that is defined below. It is fine to reference as long as it is not used to create a new contract. This is a contract which registers the creator and the assigned name. Function owned contract, byte 32 underscore name public. Owner is equal to msg.sender. State variables are accessible via their name and not via this owner. This also implies to the function, and especially in the constructor, you can call them like internally because the contract itself does not exist yet. Owner is equal to message.sender. We do an explicit type conversion from address to token creator and assume that the type of calling contract is token creator. There is no real way to check that. Creator is equal to token creator message.sender. Name is equal to underscore name. So the owner is MSG. MSG is same as like this. So creator is equal to token creator msg.sender. Name equal to name. When we say token creator, this token creator would is going to be working on msg.sender and it's going to create the creator. And name is equal to underscore name. So we are trying to save the name into underscore name, which was passed on, and the convention they often follow is this underscore name. Function change name byte 32 new name. So this is the change name. If message dot sender is equal to address creator name is equal to new name. So this creator is defined here, which is token creator. Token creator is a contract type defined below. So once that is, if message.sender is token creator, then his new name. Function transfer address new owner public. If message.sender is not the owner, then return and end it. If creator is token transfer, okay. Creator dot is token transfer, okay. Owner new owner. Owner equal to new owner. Contract token creator. So this was the first contract, own token, and the second contract was token creator. If you remember, we had this contract here. So token creator function create token byte 32 name public, returns owned token and token address. Return new owned token name. Creating a new token contract and its new address. From JavaScript side, the return type is simply address, so it is closest type available in API. Function change name, own token, token address, and byte 32 name. This own token is used a lot of time, but this is seems like this is a local thing. Okay, new return own token name. Okay, function change name own token address byte 32 name. Again, the external type token address is simply address. Token dot address dot change name. Function is transfer OK address current owner address new owner public view return boolean. Check some arbitrary condition. Address of token is equal to message, then return KECC AK256 new owner and 0xFF and byte is equal to byte 20 token address. We don't need to worry about that because we are going to look at this code slowly. Okay, functions are being specific, external, public, internal, private, but the default is public. For state variable, external is not possible and the default is internal. External function are part of contract interface, which means that they can be called from other contracts via transactions. The external function L cannot be called internally, that is f does not work, but this dot f work. External functions are sometimes more efficient when they receive large array. Public function are part of contract interface and can either be called internally via message. For public state variable, automatic gather function is generated. Internal, those function and state variable can be accessed internally, that is from within the current contract or contract deriving from it using this. Private function and state variable are only visible for the contract. They are defined and not in the derived contract. Everything that is inside the contract is visible to external observer. Making something private only prevents other contract from accessing modifying the information, but it's still available to the whole world outside the blockchain. The visibility is given after the type of state variable and between parameter list and return list function. So contract function f unit a private pure return unit b return is equal to a plus 1. Function set data unit a internal data equal to a and unit public data. So that is the contract. In the following, t can call c dot get data to retrieve the value of data in the state storage, but it is not able to call f, and so the f is a private function, so it cannot be called from outside. Okay, and then contract T is derived from C and thus called compute. This will not compile. We have contract private data set data. I'm going to skip this. Getter function. The compiler automatically creates getter function or all public state variable. For the contract given below, the compiler will generate a function called data that only take any argument and return init the value of state variable data. Initialization of state variable can be done at declaration. Contract C, we are creating a contract integer public data equal to 40. Contract caller C, capital C equal to new contract. F is equal function f public unit contact and c dot data. This is similar to like creating that contract and trying to get what is the value inside that contract. This function has better visibility. The symbol accessed internally without this. This is if the symbol this is evaluated state variable, but it can be accessed externally with this dot. This is evaluated as a function. Contract C, unit public data function x public data equal to 3. This is internal access, and unit well this dot data this is the external access. So if we create a public function, a function and data equal to 3, then this data is internal access, but if we say unit well is equal to this data, then it is an external access when we use the this command. The next example is a bit more generate a function. Okay, never mind. Function modifiers. Modifiers can be used easily to change the behavior of a function. For example, they can automatically check a condition prior to executing the function. Modifiers are inheritable properties of the contract and may be overruled by derived contract. Contract own. Function owned. Public. Owner is equal to message dot sender address owner. This contract only defines a modifier but does not use it. It will be used in derived contract. This function is inserted by the special symbol underscore colon in definition of a modifier appear. This means that if the owner calls this function, the function is executed, otherwise an accepted zone. Modifier only owner require is equal to message dot sender and underscore this. So the function is inserted using a special definition of a modifier appear. This means that if the owner calls this function, the function, otherwise it is an exception. Okay, contract mortal is owned. This contract inherits the only owner modifier from the owner and applies it to the close function, which causes calls to close only effect when they are made by the stored owner. So function close public owner self destruct owner. Contract price modifies any received argument. Modifier cost unit price if message value is greater than price. It is not, but does not use it. It uses derived contract. The function body is inserted by the special character underscore semicolon in the definition. This means that if the owner calls the function is executed, otherwise an exception is thrown. So I think this is like only going to work when the owner is going to call this. Okay, contract register is priced on mapping address to boolean register addresses unit price function register unit price public price equal to initial price. It is important to also provide the payable keyword here, otherwise the function automatically rejects all ether sent to it. Function register public payable cost price registered address message dot sender equal to true. Function change price unit price public owner. Contract mutex pool logged modifier no re-entry require underscore logged equal to true logged equal to. This function is protected by mutex, which means that re-entrant call within the message dot sender cannot call f again, return 7, assigned 7 to the return value, but still execute the statement logged equal to fires in the modifier. Function f public no re-entry returns unit message dot sender dot call returns 7. Several modifiers are applied to a function by specifying them in white spaces, separated list, and evaluated in the order presented. In the earlier version of function, return statement in function have been modified differently. Explicit return from a modifier or function body only leaves the current modifier or the function body. Return variables are assigned and control flow are the underscore in the preceding modifier. Arbitrary expression allowed for modifying argument. In context, all symbols visible from the function are visible to the modifier. Symbols introduced in the modifiers are not visible in the function as they might change by overriding. Constant state variable. The state variable can be declared as constant. In this case, they have to be assigned from the expression which is constant at the compile time. Any expression that accesses storage blockchain data, now this dot blockchain or execution data, message dot value, gas left, or make call to external are disallowed. Expression that might have a side effect are allowed, but those might have side effect on other memory objects. Built-in are KECAKK, SHA-256, RIPEMD, ECRE, COVER, ADDM are allowed, even though they do call external contracts. The reason behind allowing side effects on memory is that it should be possible for contracts constructed like lookup table. This feature is not yet fully usable. The compiler does not reserve a storage slot for these variables, and every occurrence is replaced with the respective constant expression. Not all type of constants are implemented this time. The only supported are value types and string. Solidity contract C, UNIT constant x equal to string constant x equal to ABC, byte 3 constant my hash equal to KECA to 56 ABC. So it also creates the hash value. Functions. Function can be declared view in which they promise not to modify the state. writing to the state variable, emitting the events, creating other contracts, using self-destruct, sending ether via calls, calling any function not marked view or pure, using low-level calls, using inline assembly that contains certain OP codes, contract function f unit b, public view returns unit returning to b plus now. Constant function is an alias to view. View returns unit. Okay. Okay, it's going to be dropped in version 0.50. Getting methods are marked view. Invalid explicit type conversions are used. State modifiers are possible even though the view function are called. You can switch to a compiler using static call when calling such function and thus prevent modifiers to the state on the level of EVM by adding pragma 050. The compiler does not enforce that view method is not modifying state. It raises a warning. The pure function. Functions are declared pure in which they promises not to read from or modify the state. The addition to the list of state modifying explained below the following are considered: accessing the state variable, accessing this.balance, address.balance, accessing the member of block text, calling a function not marked pure using inline function. Invalid expression type conversions are used and state modifications are possible even though a pure function was called. You can switch the compiler to use static call when calling such function. Warning: it is not possible to prevent function from reading the state of the EVM.